3.5, derivatives of trig functions. We're going to look at the derivative of sine and cosine. We're going to look at what's called the jerk, derivatives of other basic trig functions as well. So to start, the derivative of sine and cosine play a key role in describing period change. We'll talk about that further as we get into this, but for the opener, the two special limits that you're supposed to have memorized is the limit as x goes to 0 of sine x over x, which equals 1, and the limit as x goes to 0 of 1 minus cosine x over x, which equals 0. Let's look at a few examples here of some of these special limits showing up here in different forms. So what happens here when we have the limit as x goes to 0 of sine of 4x over x? Well, this isn't equal to 1, because as you'll notice here, this is sine of x over x, this is sine of 4x over x. So what I'm going to go ahead and do is multiply this by 1 in a special way. So I'm going to multiply by 4 over 4. And what this becomes is the limit as x goes to 0 of the sine of 4x over 4x, and then this 4 here I'm going to bring out in front using my properties of limits. So this right here would end up being 4 times the limit as x goes to 0 of sine of 4x over 4x, and that takes on this form that we have up here. Therefore that'll be 4 times 1, which will equal 4. In the second example, this one's a little bit more interesting in the fact that it's not sine of something over something. So let's turn it into that. Let's multiply it by, let's multiply the top and the bottom by 1 over x. Okay, that's multiplying by 1 basically. So we get the following. So I get sine of 3x over the sine of 5x over x. Okay, and then I could multiply each of those by 1 by multiplying by 3 and multiplying by 5 over 5. So now this right here, as limit as x goes to 0, that will go to 1. And this right here, the limit as x goes to 0, that will also go to 1. And so therefore I get 1 times 3/5, which is 3/5. Okay, without using your graphing calculator, sketch period of sine x. It's already sketched here for us. On the same set of axes, let's graph the derivative of sine x and see what it looks like. Let's just answer these questions first. When the sine is increasing, what's true about its derivative? Well, its derivative would be positive. When it's decreasing, its derivative would be negative. When the sine function reaches a max or min, what are the values of the derivative? 0. So I'm going to go ahead and sketch some of this stuff. So I drew a graph of the derivative, or what seems to be the derivative. These blue values are where the sine function hits a maximum or a minimum. And that looks pretty familiar. I think we'll probably talk about it on the next slide. So we graphed sine x and the derivative using our calculator, which I'm not going to do here. We actually get the derivative with respect to x of sine x. And it's kind of cool, is actually cosine x. So on my previous slide, that second graph that I drew is actually cosine x. And the derivative of cosine x is somewhat related, but the derivative with respect of cosine x is equal to negative sine x. Okay, the derivative of tangent x we can prove using sine and cosine, which I'll do off camera. So using the quotient rule, I've defined tangent as sine over cosine. I did low d high minus high d low over low squared. And it looks like the derivative of tan x, the derivative of tangent of x The numerator here is really cosine squared plus sine squared, which is 1. So 1 over cosine squared is going to be secant squared x. So the derivative of tan x is secant squared x. Using the quotient rule, we figured that out. Okay, so now a few of these you're going to want to memorize. The rest of them will be given to you. You're going to memorize these three. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. And the derivative of tangent is secant squared. So those will be, you need to memorize those. Okay, these will be given. Okay, derivative of cosecant is negative cosecant x cotangent x. Derivative of secant is secant x tan x. And the derivative of cotangent is negative cosecant squared x. A couple others to keep in mind are y equals e to the x and y equals e to the kx. Those you'll also want to memorize. Okay, so without a calculator, first let's find y double prime. So in order to do that, I got to find y prime. Y prime would be cosine x. Y double prime would equal negative sine x. So y double prime of 3 pi over 2 would equal negative sine of 3 pi over 2, which would equal negative 1, which equals 1. So y double prime of 3 pi over 2, that's kind of messy, equals positive 1. Okay, interpretation of that means that at x equals 3 pi over 2, that function is concave up. So let's look at sine x. And 3 pi over 2 would be right here. So yeah, there you go. Since the second derivative is positive, that means it's concave up at that point. Okay, in the next question here, example 3, I would use my calculator. I would type this in for y1. And I would go ahead and math 8. Okay, so math 8, that would mean d dx of that function, cosine of x over x squared, evaluated at pi over 4, right, at x equals pi over 4, and that's going to give us the slope. Let's figure out what that is on the calculator. I'm getting negative 4.0, that's a 0.65, so that's my slope. The other thing I need to do is I need to figure out what f of pi over 4 is, so I can get a point, so I can make the equation of this tangent line. So I'm going to go ahead and figure that out. I'll be right back. Okay, so f of pi over 4, or if I plug pi over 4 in there, I get 1.146. So the equation for this tangent line would be y minus 1.146 equals slope negative 4.065 times x minus pi over 4. Okay, this is my slope. This is my point. Now I have the equation of that tangent line. Okay, in the next problem, this is asking you to find a derivative basically. And what you want to do is you want to figure out what function it is. And in this case, you can see clearly that this is tangent of x plus h minus tangent of x. So the function f of x equals tangent of x, and you want to know what is x. Well, clearly you can see that this is tangent of pi. So if this wants to find the limit as that approaches 0, all that's asking for is where or what is the value of f prime of pi. It's asking what's the derivative at pi. So the derivative of that is secant squared. Alright, so I'm going to do that. Let's evaluate. Secant squared, well, secant is like 1 over cosine, so 1 over cosine of pi, and we're going to square that. Well, the cosine of pi is -1, so that's -1 squared, which is +1. So the derivative here is 1. Okay, if the line tangent to the graph of the function f at point 28 passes through that point, then find f of 2. Well, what we'd know about f of 2, or excuse me, f prime of 2, is that it's the slope between these 2 points, right? So if this is the tangent line, the slope between those 2 points should be the derivative or the slope of the tangent line. So let's go ahead and find the slope of that. Looks like 8 minus -1 over 2 minus -1, which is 9 over 3. So it looks like the slope of that tangent line is going to be 3. Okay, 2 more. For how many values of x will the lines tangent to the graphs of y equals 4 sine x and y equals x squared over 2 be parallel? So we want to know where their slopes would be the same. Okay, so what I want is I want to graph their derivatives. So this would be 4 cosine of x, and the other one would be y equals, looks like x. So I'm going to graph those. Oops, that should be y prime. I'm going to put this one in for y1 and this one in for y2 in my calculator and see where they intersect. Okay, when I sketched those or put them on my graphing calculator, I saw that their derivatives were equal in 3 places: here, here, and here. Right, this is the graph of the derivative of the second function. This is the graph of the derivative of the first function. So it looks like I get 3 values where those 2 would be parallel to each other. Okay, in this last problem it says, what's the instantaneous rate of change of f at x equals 0? So what I want is I want f prime of 0. That's instantaneous rate of change. So before I do that, I want to do the derivative. I'm going to go off camera and come back with an answer. Okay, so I used the quotient rule. Low d high minus high d low over low squared. I plugged in zeros for x using this green color here. I evaluated the secant of 0 to be 1, so I plugged that in here and here, and the tangent of 0 to be 0. So it looks like I get is 1 times 0, which is 0, minus 1 over 1 squared. So it looks like f prime at 0 would be -1. Let's see if we got that possible answer, and we do. Okay, that's 3.5. Have a great day. We'll see you next round.